All right, everybody. So I had some people asking about finding points of intersections of different lines, and I wanted to do it here on Desmos so I can check my answers by looking at the graphs. Just remember when you're working on a test or a problem in class, you can check your answer by using the graphing calculators. Desmos is a little bit slicker than the calculators we have in class, but it still works the same way. Okay, so first problem that I was asked about is y equals negative 1/2 x minus 7 and y equals negative 5x plus 10. Because both the equations are equal to y, I can make those two pieces equal to each other. So this is substitution, where I'm substituting negative 1/2 x minus 7 for the other y value, negative 5x plus 10. And we're going to get our numbers to hang out on one side and our letters to hang out on the other side. So now we have 4.5x equals 17. So dividing by 4.5 tells us that x is equal to whatever 17 divided by 4.5 is, 3.7, repeating. And so then the y value I can get by substituting 3.7 in for x either here or here. It doesn't matter which one you use. If you use both of them and get the same answer, then you know you did it right. I got negative 8.8 repeating. And I can check my answer by typing in those two equations. Just make sure you're still up to speed on why the graphs look the way they do. You can see the point of intersection. By the way, the point of intersection is exactly what we calculated. All right, so that was the first one. The second one, let's clear this out. Okay, so the second one, we have y minus 1 equals negative x minus 4, and we have y equals 0. So I'm going to substitute y equals 0 right there. 0 minus 1 is negative x plus 4. What I did is I distributed the negative, and so a double negative 4 is a plus 4. Then I'm going to get my numbers over here. So negative 5 is negative x, and then that means that x has to be 5. You can divide both sides by negative 1 if you want to show your work in that way. So x is equal to 5, and y is equal to 0, because that was given to us at the beginning of the problem. You could also take 5 and plug it back in here, and you notice that you'll end up with y equaling 0. Because if you plug in 5 right there, you have y minus 1 equals negative 5 minus 4, which means y minus 1 is negative 1, or y equals 0. But again, we already knew that. We didn't need to really check our answer that way. One tricky thing, I mentioned using the graphing calculators in the classroom. You're not going to be able to type in your equation in point slope form like that. You'd have to add 1 to both sides to get this version. See how the blue line lands right on top of the red line. And then y equals 0, you should know what that looks like. It's just the x-axis. You can see here, 5 comma 0, just like we calculated. All right, one more. This one, they both came to us in standard form, so it's a little bit more annoying. Negative x plus 3y equals negative 2. Negative 1/4 x minus y equals 2. Usually when I'm doing standard form, I'll use elimination to solve them, but we really haven't practiced elimination much, so I'll just stick with substitution and solve it that way. So I need to get one of the letters isolated. Doesn't really matter which one you choose. Let's just isolate the y value. So then 3y is negative 2, negative 2 plus x is what I meant to write. So then y equals negative 2 plus x divided by 3. And I can substitute that for the letter y right there. So we have negative 1/4 x minus y. All right, so now we have some fun with fractions. So I'm going to multiply everything by 3 to get rid of the nasty fraction. So if I multiply by 3, I get negative 3/4 x minus negative 2 plus x, because multiplying by 3 will cancel the divided by 3. And 2 times 3 is 6. Then I can distribute the negative. So negative 3/4 x plus 2 minus x is 6. Almost done. Combine my like terms. So 3/4, I'll make it a decimal, is 0.75. So I have a negative 1.75x plus 2 is 6. So negative 1.75x is equal to 4. And so x is equal to whatever 4 divided by 1.75 is. That's a crazy number. 2.2857, etc. It's some number of sevenths. Then I take that and I plug it back into y. So y is equal to, so I'll show you, I did that in 2 steps. You could also use parentheses to get it done, but I just did negative 2 plus the answer, and then divided by 3, and I get 0.09, 2, etc. in there, and graph them. And there we go. Oh, I see. I made a small mistake. So if you look here at the point of intersection, I don't know if you can see the mistake I made. The x value is actually negative. And so when I typed it into the calculator, I just left off a negative on my 1.75. So that's why it's good to check your answer. Let's see. How do I go back? Oops. There we go. So I just need to put a negative on the x value, and then I got to redo my y value. So I'm glad I double checked because I had a little mistake there. So let's go 4 divided by negative 1.75. Then I'll do negative 2 plus the answer and divide by 3. So that looks a little better right there. And so I get a y value of negative 1.429-ish. And let's see if I did it right that time. There we go. Looks good. All right, so please ask questions if there's anything confusing, and I will help out. Thanks.